All right, guys, welcome to this page of the notes. And now what we're going to do is, again, we're just going to kind of look more into this idea of restricting the domain of a rational function because you're not allowed to have division by zero. And what does that actually mean, both for the graph of the function and for finding the domain of the function? So I know what the directions say. We're actually going to go a little bit further than that. So here's what I'm actually going to have you guys do. All right, we're going to take all of these rational functions, which I have below, and what we're going to do is we're going to find the domain for these functions. All right, we're going to find the domain for all of them. But I'm going to need you to write the domains in interval notation. All right, so interval. All right, interval notation. What we're doing for interval notation is you are writing the domain values for which the function is defined. So interval notation are the domain values for which the function is defined. Now what that means is, in order to write the intervals for which the function is defined, we have to figure out where it is undefined and exclude those values. Now, the way that we do this is there's actually a couple of different things. First, I need to remind you that when it comes to sort of writing intervals, parentheses mean not included. And brackets mean included. So when we write our interval notations, if you put a number in parentheses, it means that that number is not included. It's like open and closed circles, right? The parentheses would be an open circle, meaning not included. The brackets are going to be a closed circle, meaning that value is included. All right, so we're going to write interval notation for the domain for which the function is defined. And in order to do interval notation, we're going to need to use parentheses and brackets to help show us what's included and what's not included. So here we go. Let's jump into these. Here's our first one. I give you the function f of x is equal to -3 over x minus 2. I need to figure out the domain. But first, in order to find the domain, I need to figure out what is undefined, and we know how to do that. X plus 2, right? It doesn't matter what the numerator is. We don't care. The only thing that restricts my domain is division by 0. So I take the denominator, because that's all I care about. I set it equal to 0 and solve. X equals -2. What I now know is two things. First of all, -2 is not part of my domain. It's an excluded value. I also know, thanks to what we just talked about on the previous page, at x equals -2, I have a vertical asymptote. So let me put that. At x equals -2, we have, actually here, let me put it this way. We'll have a vertical asymptote at x equals -2. Vertical asymptote at x equals -2. Why? Well, because -2 plus 2 is 0. Division by 0 on a graph will show up as a vertical asymptote. But now I know, right, that -2 gives me division by 0, and I need to exclude it from my domain. But it's the only value that's not allowed. You can pick any value of x you want to, any value at all, except for -2. Let me show you this on a number line, then we'll take a look at the interval notation. It'll make way more sense. Here's 0, -1, -2, -3, +1, +2, and here's what this tells me. What this tells me is that x, right, cannot be a negative 2. So that's an open circle on negative 2. But everything else is okay. This is the only value that's not allowed. So everything in this direction is perfectly okay. Everything in this direction is perfectly okay. So interval notation is going to look like this. We always read left to right just like you would read a page. Down here is negative infinity. Up here is positive infinity. So in order to write the domain for this function in interval notation, I'll start at negative infinity, but you have to use a parenthesis because negative infinity is not really a number, it's more an idea, and you can't include an idea. All the way to what? Well, from negative infinity all the way to negative 2. Everybody's okay except for negative 2. Now remember, negative 2 not included, so I need another parenthesis. And then what we're going to do is use this symbol. It's going to look like a U. It means the union. So I'm taking this entire set of numbers from negative infinity to negative 2, this set of numbers. I'm going to join that or union that with this set of numbers, starting at negative 2, but parenthesis because it's not included, all the way to positive infinity. Here's what this interval notation tells me. I take a look at this interval notation. It says from negative infinity to negative 2. Everybody's okay. You can pick anybody you want to except negative 2, and I know that because of the parenthesis. Negative 2 is not included, so you can't use negative 2. Union that, right, including, right, these values and these values, starting at negative 2, but it's a parenthesis because negative 2 is not included, open circle, all the way to positive infinity, right? And so the way you read this is the domain is all real numbers, negative infinity to positive infinity. You can pick anything you want to except negative 2, right? Negative 2 is not included. All right, guys, I hope that that makes sense. We'll try a bunch more here. I got several example problems below, so we'll give those ones a try. I'll meet you there.